Hi, my name is Jordan, and today I'm going to teach you a little bit about solving trigonometric proofs, where we demonstrate how one expression is equal to another. Don't worry if you don't know much trig, we only need a few basic functions. Here we have sine theta, cosine theta, and tangent theta. Tangent theta is equal to sine theta divided by cosine theta, where theta can be any real number. One last thing we need to know is the Pythagorean identity, which states that sine squared theta plus cosine squared theta is equal to 1. For our purpose, don't worry about where it comes from. We just need to know that it's true. Let's get started. Here I have a statement that says 1 divided by cosine theta is equal to sine theta times tangent theta plus cosine theta. We know that the left side is equal to the right, but it's our job to prove it. Think of it this way. Here are two Rubik's Cubes. One is solved and the other is all mixed up. We know that they're the same cube, but the one on the right does not look like the one on the left. To show that they're the same, we manipulate the mixed cube until it looks like the solved one. The same concept applies to our proof. We're going to manipulate one of these expressions using trig functions, the Pythagorean identity, and basic algebra until we can show that it's the same as the other side of the equation. To start, we have to pick a side to change up. I'll give you a tip. It's usually easier to change the more complicated side. Think back to the cube example. It's easier to solve this cube and simplify it to have all 6 sides a solid color than it is to take the solved cube and get it to the exact pattern of this mixed one. But don't worry, our proof is much easier than solving a Rubik's Cube. This equation, I'm going to pick the right side because it has a little more action compared to this 1 over cosine theta. What happens now is that we can do anything to our expression mathematically as long as we don't change its value. Looking back at the solution, we want this entire expression to be condensed into one fraction, which means that we'll need to be combining terms. If you remember our basic functions, you know that tangent theta is equal to sine theta divided by cosine theta, so we can substitute that in here. Multiply it out and we're left with sine squared theta divided by cosine theta plus cosine theta. But we're not at one fraction yet, so let's continue combining. The easiest way to do that is by using a common factor to add these two terms. Cosine theta currently has a denominator of 1, so if we multiply it by cosine theta over cosine theta, we have two fractions with the same denominator, and we can add them together to give us sine squared theta plus cosine squared theta all over cosine theta. Boom! Everything is conveniently in one fraction with a denominator of cosine theta, which means that we're close. Now take a look at our numerator and think back to the Pythagorean identity I mentioned earlier. And see the expression we have here? That means we can substitute for 1, leaving us with 1 divided by cosine theta. Our equations are now identical, meaning that we're done. If you're fancy, you'll end it with Q.E.D. Even if math isn't your thing, trig proofs can still be fun because they're more like logic problems than anything else. Once you get more advanced, you can solve proofs using other trigonometric functions and identities like these. There are tons of proofs out there for you to enjoy. So until next time, happy solving!